this video, we are going to see the next higher order thinking problem on functions. We have already seen few problems which involved hybrid concepts. This problem is basically based on the concept of identical functions. So let's see what do you mean by identical functions, and let's then solve the problem for both the parts A and B. Let's read the question first and let's get started. The question asks me which pair, this pair in A part is the first one and this is the second part. So which pair of these two functions is identical? What do you mean by identical? Otherwise in English language, identical means similar or same. We say that two twins are identical. We say that one red bag and the other red bag of the same company, of the same size, of the same price are identical. So identical means same. Similarly, in mathematics, functions are identical when the domain is same and the range is same. That means both the things should be same, the domain and the range both. So let's get started by doing the first part and we'll understand more about identical functions then. I have fx is equal to under root x square, gx is equal to x in my first question. Now what about fx? It is under root x square. That means what is the domain of fx? I will write d as domain and r as range. Right. So what is domain of fx? That means what value of x can you put in fx? You can put any value, whatever value you put. That will become square and can be solved for under root. So domain of fx is all real. What about the range of fx? The range of fx means what values will you obtain? Under root will give me only positive values. So 0 or greater than 0, that means greater than equal to 0. Now move on to gx. What is the domain of gx? Domain of gx means what values of x can you put in gx? No restriction, you can put all the values, negative, positive, 0, anything. So again it is all real. What about the range of gx? What values will you get as a result from gx? You can get all the values, all real. It is not that you will get only positive values. You can get all real. Now check whether the domain of fx and domain of gx is equal. Yes, it is all real. It is equal. Now check whether the range of fx, range of gx is equal. No, it is greater than equal to 0. It is all real. So these values of range are not equal. That means both domain should have been equal, range should have been equal, then only we had got identical. But since here range is not equal, so I don't have identical function. So he asked me which pair is identical. I don't know about the second pair till now, but I know that the first pair of fx and gx is not identical. So this value is not identical. It is not identical. The first pair is not identical. Let's move on to the second pair. Follow the same technique. Do the same methodology. Write fx, write gx, write domain, write range. Now fx is equal to x upon x. What values can you put in x for fx? You can put all the values except x is equal to 0. Because if x is equal to 0, denominator is 0, not defined. So domain of fx means all real but not 0. So it is real minus 0. What about gx? Gx is already 1. So there is nothing that you can put. It is just a constant quantity. It is always 1. Since the domain of fx is all real minus 0 and gx is actually equal to 1, so these will never be equal, and since these are not equal, I just say that they are not identical. So not identical again. So what is the funda to check whether things are identical or not? You just need to see the domain, you just need to see the range. If the domain is equal, range is also equal, only then I have identical functions. If either of the things are not equal, then my functions are not identical, as in both the cases. So even in the second case I have to write it is not identical.